This is the video for the first PowerPoint in Chapter 8 in the McGraw-Hill textbook. So the 5 sections, we're going to talk about the covalent bond first. Last chapter, remember, was about ionic bond. We're going to name molecular compounds, molecules, then molecular structures, molecular shapes, and then we'll talk about electronegativity and polarity. Those are the 5 parts. So this first one pretty much going to focus around the covalent bond. Covalent bond is similar in some ways to the ionic bond we did in the last chapter. If you remember, we talked about the octet rule. The reason that atoms bind together, whether it be covalent or ionic, is that they want to be stable, want to be more stable. And they do that by trying to get an outer configuration similar to that of the closest noble gas for most of the A elements. On ionic compounds, they are far apart from each other, and being far apart, they have wide difference in electronegativity. Remember, the electronegativity gets stronger as you go left to right and as you go bottom to top. So fluorine has an electronegativity of 4. Francium would be one of the lower ones on the bottom left corner. So ionic, remember, we have ion both sides, so they are on 2 sides of the stair step. We have a metal and a non-metal, and the metal and non-metal combine, and one of them steals electrons from the other. When it steals, it becomes negative when because it's gaining the electrons. The one that loses the electrons, minus a minus, makes a positive ion. Plus and minus attract. Well, here we've got 2 that are above the stair step, so they're both nonmetals. And they're very close in electronegativity, so they're kind of like a tug of war where it's a tie. Not one or the other are able to beat each other, and they end up, instead of stealing electrons, they end up sharing electrons. So we're going to have 2 nonmetals from above the stair step. Covalent bond is a sharing between 2 nonmetals. Good examples are the diatomic elements. You should know these 7. Easy way to do that, get a periodic table in front of you. Look at number 7, nitrogen. There are 7 that start with 7 in the shape of a 7. So just about anybody can remember that. And we've got nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and of course the 7th one is hydrogen. They occur as pairs because they're more stable that way. And we'll talk about some of those as we go on the next 2 or 3 screens and talk about bonding. Make sure you know the 7 diatomic elements. That's really important the next, well, really all year. All right, single covalent bond. So we're going to start out by talking about hydrogen, and you can see on your notes there that hydrogen is one of the covalent. Bromine, fluorine are also. They all do single bonding. So here's hydrogen. Has 1 dot. It's in 1A, 1 dot. If you remember your dot diagrams, the Roman numeral of the A tells you how many dots it's going to have. Here's another hydrogen. I'm going to use X's for that one. Whenever we do adjacent atoms, I want you to use dots for one and X's for the other, so I know where the electron came from. That's the same as a dot. We're not changing it to X diagrams. They're still called dot diagrams. And another point is that electron dot diagrams, Lewis dot diagrams, Lewis dot structures, they're all names for the same thing. So when we refer to them in those different ways, you need to be able to handle all of those terms. So there you go. Hydrogen, this hydrogen had the dot, it gave 1. This hydrogen had the X, gave the other one. And they're sharing. Now, remember, hydrogen, the first ring, can only have 2 electrons, and 2 makes it happy. So there we are. There's 2 electrons now, and we could draw circles. You're not required to do this. It's probably not even the best thing, but it helps you at the beginning to help know when we are going to count that electron and that electron both count for this hydrogen. That electron count for this one. The way we show that they are being shared is we put them between the 2 letters. So There you go. That is H2, and that's why it occurs, because now it's stable. It wasn't before because it only had one electron. Same thing with bromine and chlorine and iodine. They all have 7 dots. So here's Br, 1, 2, 3, 4, 5, 6, 7. And then the adjacent bromine, we're always going to put one shared because we know there's going to be at least one shared. So that we've got X, 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 7 dots, 7 dots. Now they're shared. And we count 1, 2, 3, 4, 5, 6, 7, 8. We count both of these for both bromines because they're being shared. So that's how we have the single covalent bond, and that's why all of those occur as diatomic pairs. So double covalent bonds. We're going to look at another one, oxygen. That oxygen is one of the diatomic elements. And here's O and an O next to it. This is how we do all of these diagrams. We put both letters side by side, do the dot diagrams. We've got 1, 2, 3, 4, 5, 6. And then the other oxygen, 1, 2, 3, 4, 5, 6. Now we count them, and when we count them, we see that there's 6 around each, but we're sharing one with the neighbor, so now it's 7 and 7. We're not happy yet, and that's how you do these every time. Do the dot diagram side by side, share one, count. If it's not 8, erase, and share another one. There you go. Now we've got 8 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you're going to do the same thing every time. You're going to put the letters next to each other, whether it be 2 or 3 or 4. Put the letters next to each other, do their dot diagrams, share one electron, and then count. Share another and count. You keep going until you get 8 and 8. Everything's happy, then you're done. So in this case, now we have O2. It's sharing 2 electrons. And we could also draw this as a structural diagram with the O and 2 lines. The 2 lines represent 2 pairs. Each shared pair corresponds to a stick on the structural diagram. We'll talk about those different models later. So we move on, and we're going to talk about oh, that's not moving. Okay, so we're going to move on and talk about nitrogen, which is on the next screen, and this happens to be a triple bond. Same process as before. All right, so there we go. We got to the next screen. So nitrogen has 5. So we're going to draw the N and an N next to it. Remember, we're showing 2 nitrogens bonded together. And so we're going to show 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Not happy because when we shared, now instead of 5 and 5, we've got 6 and 6. So we're going to erase one from either side. Share again. Not happy. It's 7 and 7. Erase one from each side. Share. And now we've got 6 and 2 and 6 and 2. If you want to draw the circle, you can. So the ones that are in between here are being shared between both atoms. Because they're being shared with both atoms, we've got 3 pairs, and 3 pairs corresponds to a triple bond. You can see here we've got N with 3 sticks. This is how the structural diagram would look for that same compound. And nitrogen, one of your diatomics, it's N2 when we do the formula. We'll do one more of those triple bonds, do one a little bit more complicated, a little tougher. And, you know, the good thing about the ones that I'm showing you is that if you do the ones that I show you, the ones you have on your practice page, you'll probably see some of those same ones on the quiz and the test. I'm not going to go look somewhere for some that we haven't seen. You'll probably see some of the ones that we've gone over. So those people that pay attention and do their practice, you'll get rewarded in that way. So next one we have is HCN. And people say, well, what order do we write it in? If you don't have any other thought about order, write the order that it comes to you, HCN. That's the way it's written. That's the way I'd write it. So hydrogen has 1. I'm going to use the X for that. C, carbon has 1, 2, 3, 4. Notice that I've put 1 in between the letters for each element because we know we're going to be sharing at least 1. So go ahead and put it there to start out with. Nitrogen, I'm going to use X's for that too. We've got 1, 2, 3, 4, 5. So let's look at what we've got now. Hydrogen has 2 since carbon has given it 1. 2 is good. Hydrogen's done. We don't need to share any more with hydrogen. Carbon has 1, 2, 3, 4, 5, 6. Nitrogen, 1, 2, 3, 4, 5, 6. That's a good sign when you have the same number, but they're not happy yet. What do we do when they're not stable? Erase and share one more time. Okay, so now we've got dot X, and now we've got 7 and 7. Not happy, so we're going to erase another one, and we'll put a dot and an X in there. Now we've got a triple bond between the carbon and nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. I'll move this one out here because the electrons will be pushing it away. So we've got 8 around nitrogen, 8 around carbon, 2 around hydrogen. Everything checks out, and we're done. So that's another one that's pretty common that you'll see triple bonds. As far as models of covalent bonding, there are 3 or 4 models that we use. One of those we've done a lot of so far, and that's the dot diagram. Remember that the dot diagram, Lewis dot diagram, Lewis dot structures, those are all the same thing. So don't confuse it just because you see a different terminology. So Lewis dot diagram, we just did one of those. How would that HCN, remember dot 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 X, 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 and then we had X and X here, and we had an X and a dot. So there's your dot diagram. Remember I use X's because that shows me that nitrogen gave 3 of these, and carbon, which is the dots, gave 3 also. So it tells me a little more information than if you just use dots everywhere. And during our practice phase, I'm going to require that you do that. So what would that look like? Well, there's 1 shared pair, that's a stick. There's 3 shared pairs, that's 3 sticks. And that's it. That's the structural diagram. We don't show unshared pairs like these. These are not shared, so they're not shown here. But we do have a diagram that will do that, or a model that will do that, and it's kind of a morph between the dot diagram and the structural, and we call it a structural dot diagram. The only difference is that it has all the structural part, the sticks, and then we also show the dots for unshared. So that way it's kind of showing us everything the dot diagram does, but the sticks are a little bit easier to read what's going on. Each stick stands for 1 pair. That's shared. We also have the space filling model here. So this ball and stick model, also called space filling, that's what you're going to be doing on your lab. You're actually just making a picture of the model that you built. This one is also called space filling model. It's more of what the molecule would actually look like if you zoomed in and you were the size of an atom and you could see it. So this is a list of the vocabulary at the end for the whole chapter. I would go through this, make sure that you know what each term means. You know, some of these, 3 or 4 of these, I know for a fact will be on the quiz, so that you'll see some of those as the multiple choice answers. That finishes up the lecture A. So we've got that done. Be a good idea for you to go through this, each of these lectures. When you get something, great, move on. When you don't, you can stop and rewind anytime. Remember to have your PowerPoint handy and have a periodic table handy with your possibly useful. Work hard, do lots of practice, and good luck.